Okay, guys, so you should have gotten these instructions from the back of the table as you were walking in. These are your instructions for today. So you're going to get the notes out from yesterday, which are the ones that look like this. And you're going to turn to this page right here that I'm showing you in the instructions, which you just turn and they're right here. Watching this video, you're going to fill out these notes. As I said, there's maybe some questions and we're going to get this for a grade. This is a summative. You can redo this assignment until you get 100. Have in mind, this is a summative. It's to help you out. Okay? So after you finish this video, it's going to be on wave ground, right? You're going to go and complete the assignment that we did yesterday that's in IDEA. And it, remember, it's called Independent Practice, Polygons, Interior and Exterior Angle Sums. And remember, you're going to show your work on this separate sheet of paper that's behind these, on this one. This we're going to show your work for the rest of the 4 problems. You should have done 6 for homework and you're going to finish it off. Okay? As you know, you cannot take it for homework. You're going to turn it in at the end of the period. Okay? Let's say you finish the video, this video, you finish the independent practice that was we started yesterday, then you're going to stay on wave ground and you're going to go and look for the assignment called area of regular polygons, and you're going to show your work on the separate sheet of paper that's stapled behind these instructions. This is where you're going to show your work for that assignment, and you're going to turn it in. You're going to turn it in, done or not, guys, so please make sure that you're using your time wisely. Okay, now we're going to go into today's lesson. We're going to finish off Unit 5. So now I'm going to teach you how to find the area of a shape like this. So let's start with the background information. So this is a regular polygon. Remember, regular means that all the sides and angles are congruent. That's the word regular. If the word regular is in front of the polygon, that's what you need to know. The sides and angles are congruent. So in here, you need to know that the distance from the center of the polygon to any side, that side is called the apothem. Okay, what is the apothem? Remember, it's the side, the apothem is the side that gives you the distance from the center to the side. So this one right here will be the apothem. The distance of that line will be the apothem. And then the radius of a regular polygon is the distance from the center to the vertex. The vertex is just another word for the corner of the polygon. So the radius is the line that goes from the center to the corner of the regular. So that one is it. So this line in yellow is the apothem. This line in pink is the radius. Okay. And there is a formula to find the area of a regular polygon, which is 1/2 times A times P. The A means the apothem. So that means that you need to get the measurement of the apothem of this line. You need to find the distance of that line. Okay. And multiply it by P, which is the perimeter. How do we get the perimeter? We add all the sides. We add all the sides of the shape. That's how we get the perimeter. And another way to rewrite this formula is like this. If you are getting confused with the fraction, it's going to be the area of a regular polygon equals to A, the apothem, times the perimeter, and all of that is going to be divided by 2. That's how you find the area of a regular polygon. Okay, so in here, this is what we're going to do. We're going to find the area of a regular polygon. So the word regular means that all the sides and all the angles of that shape that are congruent. Okay, so that means that if this side right here is 24.2, that means that this side is also 24.2, and this side right here is also 24.2. So we're finding the area of regular polygon, so you should write your formula. The area of polygon equals to the apothem times the perimeter of the shape, and all of that's going to be divided by 2. Okay, so the apothem is this one. Remember, it's the distance from the center of the polygon to the side, of the shape. And you're going to look for that 90-degree angle. So the apothem, the value of the apothem is 7 feet. And then you have to find P, which is the perimeter of the shape. So what you have to do to find the perimeter of the shape is add all the sides. So that means I'm going to add 24.2 plus the other side, 24.2 plus the other side, which is 24.2. So what do you do to get the perimeter of the shape? You add all the sides. Since this is a regular polygon, it means that all these sides have the same measurements. So we're going to be over here. We're going to go 24.2 plus 24.2 plus 24.2. That gives me 72.6. So the perimeter is 72.6. Okay. And we're going to put our values there. So the opposite, it's 7. So it'll be area of a regular polygon is opposite, which in this case is 7 feet, times the perimeter. When we add all the sides, the perimeter we found out is 72.6. And then we're going to divide all that by 2. Then I'm going to multiply 7 times the perimeter, 72.6, equals to 508.2. And then don't forget that we're still dividing by 2. So I'm going to divide that by 2. And that equals 254.1. Okay, and remember this, what are the units? The units are feet. And remember, we're finding the area, so that means that the units are going to be to that second power. So the area of this regular polygon is 254.1 feet squared. Okay, and then you're going to do this on by yourself. So I'm going to grade this when you turn it in. And then we're going to move on to the next problem right here. On this problem, it says the following. A regular pentagon has an area of approximately 42.23 feet squared and a side length of 7 feet. What is the approximate length of the opposite? So I don't know if you remember when we're going over finding the area of a trapezoid. And here we're doing backwards. Now they're giving the area of this regular pentagon, and you need to find the opposite. So since they're giving you the area of a regular polygon, you need to use this formula. A equals opposite times the perimeter, and all that divided by 2. And we're going to plug in the values that we know. We know that this regular pentagon has an area of 42.23. So that's the value of A because A represents the area. We know that this is a pentagon. So a pentagon looks kind of like this. And you can always go and reference. I know it's not the perfect pentagon, but that's what it means. And if you still don't know, if you turn your page, I give you the reference sheet paper. So you see pentagon? This is how it looks. It has 5 sides. Okay? It has 5 sides. So that means that the side, since this is a regular pentagon, it means that all the sides are congruent. They have the same measurement. If one side length is 7, it means that all of these 5 sides are also 7 feet. All the 5 sides are 7 feet. Okay? And this is important because we're going to need that information because do we know the opposite? The lowercase a, the opposite? No, that's what they want us to find. What is the opposite? So that's our x. And in this equation, we need the perimeter. And how do we know how to find the perimeter shape? We need to find all add all the sides of this shape. So that's what was very important for us to know what was the side length of the pentagon. Because this is a regular pentagon, that means all 5 sides are congruent. So how do I find the perimeter of this pentagon? Add all its sides. So this is side 7, plus this side 7, plus this side 7, plus this side 7, plus this side 7. So I'm adding all 5 sides, which are all 7. Okay, so over here is going to be 7, plus 7, plus 7, plus 7, and plus 7. So to find the perimeter, that means that the perimeter is 35. So the perimeter here is 35. And we're going to plug in the values where they go. Do we know the value of the area of the regular pentagon? Yes, it tells you right there is 42.23. Equals to the opposite. Do we know it? No, that's the missing value, so I'm going to switch it for an x. Times the perimeter. Yes, I know the perimeter is 35. Okay? And all of that, according to a formula, we're all going to divide that by 2. And your goal is to do inverse operations. That means leave x by itself. So in this inverse operation, we first need to get rid of this 2 of the division of 2. How do we get rid of the division of 2 in a inverse operation? We do the opposite, so we multiply by 2. And what we do to one side, we do to the other. So on this side, I'm also going to multiply by 2. So over here, to solve for this side is 2 times 42 times 0.23 right there, which gives me 84.46. And over here, when I multiply this side by 2, I cancel this out. And I'm left with x times 35. So we need to leave x by itself, the opposite. So we have to do the inverse. What's the inverse of multiplication? Is division. And who do we need to get rid of? The 35. So since we're multiplying by 35, the opposite is to divide by 35. And what I do to one side, I do to the other. So that means I'm going to divide 84.46 by 35 by its perimeter, which gives me, well, I'm going to round to the nearest tenth. So it gives me, since it's 2.41, when I round up to the nearest tenth, it's 2.4. That's the value of x, because over here, this cancels out. So that means that the opposite is 2.4 feet. So that means that if I were to write a line from the center to this side, that's the opposite, and the measurement of the opposite is 2.4 feet. That's what I'm looking for. Okay, so that is it for today. So if you have any questions, you can go back and look at this video. You're going to do these 2 questions on your own, and I'm going to grade them when you turn in this page. Okay, so continue working.